In this short lecture video, we will be learning few facts about unsigned magnitude as well as signed magnitude representation of numbers. First of all, we will be learning what can be represented using both unsigned magnitude as well as signed magnitude form. Using unsigned magnitude form, we can only represent the positive numbers. Whereas using signed magnitude form, we can represent both positive as well as negative numbers. Now secondly, we will be knowing what type of bits are there in a number. If it is an unsigned magnitude representation, then all the bits in a number are magnitude bits. However, if the representation is a signed magnitude representation, then in the number there will be one signed bit and remaining will be magnitude bits. The signed bit will be the leftmost bit of the number, and if it is 0, then it is a positive number. If it is 1, then it is a negative number. Now let us know what will be the range of numbers that we can represent for n binary bits. If it is an unsigned magnitude form of representation, then using n binary bits, we can represent the number starting from 0 to 2 to the power n minus 1. So for an example, if n value equal to 4, then we can represent the number starting from 0 to 2 to the power 4 minus 1, which is nothing but 0 to 15. So total of 16 numbers, right? Using 4 bit, we can represent 16 numbers. Now in case of signed magnitude form, we can represent the range of numbers starting from minus 2 to the power n minus 1 to plus 2 to the power n minus 1 minus 1. So in this case, if n equal to 4, this will be equal to minus 2 to the power 4 minus 1 to plus 2 to the power 4 minus 1, which is nothing but equal to from minus 7 to plus 7. Hey, wait, now you will say that from minus 7 to plus 7, it is total of 15 numbers. But using 4 binary bits, I should be able to represent 16 numbers. In case of signed magnitude form, you also represent 16 numbers, but in this case, 0 has 2 representation. One for plus 0, another for minus 0. So if I will write 0 0 0 0, where 0 is the signed bit, it will be positive 0. If I will write 1 0 0 0, where 1 is the signed bit, it will be negative 0. Now we will be learning how many bits required to represent a number. This we will learn using one example. Let us say I want to represent plus 7. Now using an unsigned magnitude form, I will need only 3 bits to represent 7, which is nothing but equal to 1 1 1. However, using this signed magnitude form, I cannot represent plus 7 using 3 binary bits only. I would require 4 binary bits to represent plus 7. So the representation of plus 7 in case of signed magnitude form will be 0 1 1 1. So in case of unsigned magnitude form, you require 3 bits to represent plus 7. However, in case of signed magnitude form, you require 4 bits to represent plus 7. Now in the comment section, you just let me know what is the largest number that I can represent using 3 binary bits as well as signed magnitude form. That's all for today's lecture. I hope you have learned few important facts about signed as well as unsigned magnitude representation of number. If you have loved the video, then please like the video, share it with your friends, and write your comment below if you have any doubt. If you have not subscribed to VLSIFacts channel, then please do it, and also do not forget to press the bell button. I will come with another lecture video. Till then, take care. Bye bye.